Dear students, in the previous class, we have discussed the 5-number summary consisting of minimum, Q1, Q2, Q3 and maximum. Now in this class, we discuss the graphical representation of this 5-number summary. This graphical representation is known as box plots, also known as box and whisker diagram. Box and whisker diagram. So box plots is based on the 5-number summary, and it provides a graphical display of the center and also the extent of variations in a data set. And it was invented by John Tukey. Invented by John Tukey. To construct a box plot, we use the concept of adjacent values. We use the concept of what is known as adjacent values. Adjacent values of a data set are the most extreme observations that lie within lower and upper limits. Adjacent values of a data set are the most extreme values that still lie within upper and lower limits. And remember this, if there are no outliers, in the last class we have discussed what is an outlier. Now if there are no outliers, the adjacent values are minimum and maximum values. The adjacent values are nothing but minimum and maximum values. Now let us see how to construct a box plot. We explain the construction of a box plot with the example we have discussed in the previous class. It was based on the observations 5, 15, 16, 20, 21, 25, 26, 27, 30, 31, 32, 34, 34, 35, 38, 38, 41, 43, 66. Now for this data set, as we have calculated, Q1 was 23, Q2 was 30.5, Q3 was 36.5. There is an outlier. The outlier was 66. Adjacent values are 5 and 40. If there are no outliers, adjacent values are minima and maxima. Adjacent values are 4 and 5 and 40. Now let us see how to construct a box plot. The first step is to calculate the quartiles. Calculate the quartiles Q1, Q2 and Q3. The second step is determine the adjacent values and also potential outliers outliers, adjacent values and outliers. Now the third step is draw a horizontal axis. Let the horizontal axis is this, a horizontal axis on which the numbers obtained from the first two steps can be located. Now in our example, these values vary between 0 to the maximum value is 66, so 70. 0 to 70, a horizontal axis is drawn where we can plot the values, quartiles, adjacent values and outliers. Then above this axis mark the quantiles and adjacent values with the vertical lines. With the vertical lines 10, 20, 30, 40, 50, 60, 70. So Q2 is 30.5, Q3 is 36.5, Q1 is 23. Then the adjacent values are 5 and 43. Adjacent values are 5 and 43. And the fourth step is connect the quartiles with the lines like this. Connect the quartiles to make a box. Connect the quartiles to make a box. Remember this. This is Q1, this is Q2 and this is Q3. And the adjacent values are connected with the lines. Adjacent values are connected with the lines. Adjacent values are connected with the lines. And plot the outlier, in this case 66 with an asterisk. With an asterisk. This is how we construct the box plots. The box plot. Q1, Q2, Q3. Then these are the adjacent values. This is the outlier. And the lines extending from the box are known as whiskers. This is a whisker. This is also a whisker. The lines originating from the box are known as whiskers. Then the boxes are also drawn vertically. This is drawn horizontally, vertically is also, depending on the software you are using. And the outliers can be represented by other symbols also. And as you can see, the distance between these vertical lines show the extent of variability. And the width of this box is the value of interquartile range. That is Q3 minus Q1. That is IQR. IQR is equal to Q3 minus Q1. So the width of the box is nothing but the interquartile range. And this is the spread of observations in the first quarter. This is the spread in the third quarter. Spread in the third quarter, and box the spread in the first, second and third. This is the spread in the fourth quarter. So first quarter, second, third, fourth quarters. And as you can see here, the spread is low in the third quarter compared to the second, and here the spread is much larger than this. So the box plot will give you an information about the location, that is the median, and also the extent of the variation. And it is one of the most widely used methods to display data. Also, box plots can be used to compare the extent of spreads in two populations. For example, suppose that 0, 5, 10, 15, 20, 25, 30, 35. Now suppose that for one data set, it is like this. It is like this. For another data set, it is like this. And you can compare two things where the location is for one data set, for another data set, and the extent of spread in one data set, the other data set, and also the range of interquartile range, and also the extent of spread in the first quartile, second, third, fourth, first, second, third, fourth, like that. And for a right skewed distribution like this, a right skewed distribution like this, this is Q1, Q2, Q3. So the box will be like this, and the spread will be like this for right skewed. For left skewed, the box plot will be like this. Box plot will be like this. And for a normal distribution, for a symmetric distribution, the box plot will be like this. Like this. For a right skewed, for left skewed, and for a symmetric. And this is the box plot. And the box plots are extensively used to display the data, because it will give you information about the location of the data sets, and also the extent of the spread, and also the spread within different quarters. In which quarter the spread is high and in which quarter the spread is low. For a skewed distribution, you can see the spread is the largest in the fourth quarter, right skewed. For left skewed, the spread is the largest in the first. For a symmetric distribution, the spread is same in the first and also fourth quarters, like this. That is all about box plots.